All right, Workplace 20 fans. This is it, the last section, 2.4, circle graphs. All right, so in our continuing journey in graphing, we'll learn in a roundabout way. That was a joke on purpose. Take a look at circle graphs. Circle graphs are a visual representation of data made by dividing the circle into sections that each represent a part of a whole. So again, it's a little bit different. We also call a circle graph a pie chart. Pie. All right, so a circle graph is a good visual representation. I really like it too because it's different than some of the other graphs we're using there with, like on graph paper with the X and the Y variables going on there, because you can change the scale on things. What's neat about a pie graph is that, you know, whatever data you have, it's consistent with it. So again, ready to see proportional amounts, and it's far like you misrepresent. Right, so that's why I really enjoy circle graphs. So if we take a look here at this example here, we got, again, there's the title, right? Top 5 tour destinations of Canadians. And again, you can see here a nice legend. It tells you what each of these parts are representing. So it's really important to label. A legend is great. Sometimes people will label right on the piece of pie that's making up their graph. All right, so when we take a look at this, we can definitely see that this part here, Mexico takes the biggest piece of pie. So I guess a lot of snowbirds are going down there and traveling down to Cuba based on this. Approximately what percentage of people visiting these countries visited Cuba? Okay, remember 100% equals the whole circle. So all of this is 100%. And it looks like about 1/5 here of the pie is taken out, so approximately 15 to 20%, right? 1/5 is about 15%, right? About 20%, right? So that's because it said percentage, didn't say how many people. All right, so this graph indicates percentages of visits to various countries. At least these two things you cannot determine from the graph. Like you can't tell how many people. It didn't give us a number like 1,000 Canadians, right, or left. It didn't ask how many people were polled, you know, because maybe some people also wanted to go to other countries, you know, and that's not in there, and how long they spent there, even time of year. So there's lots of things this graph doesn't tell us, but it gives us a little bit. So, you know, when I look at this, I see 3 warm climates, maybe snowbirds, and because some of Canada's roots are based on French and English heritage, a lot of people are going back to France or United Kingdom. Maybe they have relatives there. That's what I'm kind of reading through this circle graph here. Great. Example number 2, you got Mark as the foreman here of this construction site. He's concerned that some workers are getting accidentally injured at work. So he's looking here again. I can't stress enough. There's the title. Here's the legend. It all looks good. It's all easy to do this and to make sense of this all. So this happened over the past 5 years, right? And it says what percentage of the injured workers were painters? Well, if you look here, the painter is a little squiggly, about 3%. Now, this is where the math gets in once you start to put some numbers of people. So if there was a total of 33 workers were injured, how many of them were electricians? So again, you see that the electricians would make up 6%, right? So you'd have to find out what 6% of 33 is. So you put 0.06 times it by 0.33, you get 1.98. Now again, you can't have just 0.98 of a person. It's got to be a complete person. So we're going to round that up to 2 electricians were hurt out of the 33 people in the last 5 years. Okay, well, which appears to be the most dangerous job? Well, can you say this for certain? Well, if you look at this, it definitely looks like, you know, plumbers at 27% would definitely be your highest level. But we can't just, like, what does danger mean? Like, these are injuries. What were the injuries? Were they, you know, you hurt your finger, or, you know, you hurt your knee, or did you get an arm ripped off or fall and have concussions? Like, there's different ways you can look at dangerous, right? So you can't really tell based on that. It appears that plumbers are getting injured the most. Maybe they're having back problems from scooching down a lot and not stretching and doing that. But this is definitely a graph that an employer would want to look at and try to figure out ways, because when somebody's hurt, that's time away from the job site, and that's losing money. And of course, more importantly than money, you don't want to see anybody hurt. So it's important to look at graphs like this and figure out strategies to make the workplace safe. All right. Now, if you can, this is our last example here that we'll be looking. Now, we'll also need this in a future unit when we look at budgeting down the road. So you should really pay attention to this one. Again, here you've got your data. So your different categories are listed here. And then it gives you your hours. So in order to do this, you have to add up how many total hours were in, and there's 24 hours in a day. So that becomes our denominator for all the math that we're going to do for each section, right? And we got to find out what percentage of the day is spent doing these variety of activities. So it's really important to do that. So that's why we're going to set up proportions. Now you can see here that 7 hours is sleep, right? So 7 of the 24 hours were spent sleeping. Now, if you set up a proportion and you put x over 360, what you can get there is, the reason you use 360 is because there are, all the way around, 360 degrees in a circle. All right, so that's why we use 360 here. So what percentage of degrees would that make? So you can see here you cross multiply and divide, and you can see this here is 105 degrees. So when you take your protractor, you would put your protractor down in the middle, right? 0 would be here, and you would read up all the way to 105 on your protractor, put a tick, and then you would slice out your little section of 105 degrees, right? School's the exact same. You can see you have the 7. So again, I put my protractor here. This would here would be where my 0 would, and I would try to get this to go to where 105 degree is, right? So that's how you would set up, and that's how you would draw that. So you can see all the examples here, how they did that, all right? School, job, again, forward 24. There's where you get your 4. There's your job. You can definitely read your graph. You can see the majority of time is spent sleeping or at school. Job takes out a big chunk of the pie, and then traveling, relaxing, and meals. They're all fairly equal there. That, you know, like you got 2 hours, 1.5, 1.5. One's a little bit, you know, transportation back in school. So this gives you a little bit look at how your day might come in. So again, if you add up all the degrees, it should equal to 360, and to make sure that you're good to go on that, right? Again, you draw a line from the center edge to the radius to measure each section from the end of the one before. Make sure you measure the last section to check you got it all correct. Okay, so that's with our little friend, the protractor, from 0 to 180. All right, check out the assignment on page 107. Do 1 through 3 in your workbook. Again, do the formative so I get some feedback and see, make sure you understand this. Post to the form, get on Flipgrid, and let me know what you're thinking of this. And also feel free to contact me through email or remind. All right, so that's it on circle graphs, and that wraps up our section on graphical representation. Thanks for watching. Good luck, and we'll talk to you soon.